Hello, welcome back to my computer aided measurement and control lecture. In this topic, we are going to talk about Arduino with switch and then buzzer and also ultrasonic distance sensor. In this particular topic, we still do about digital output and also digital input. The objective is learning how to operate with digital input and output in Arduino Uno, and learning how to deal with switch, buzzer, and ultrasonic distance sensor. This kind of device you need for this lecture, of course, Arduino Uno and switch, and also you still need LED, and this one is buzzer, and this one is ultrasonic distance sensor type of SC SR04, and you still also need the resistors, the value 220 ohm and 10 kilo ohm. And in this subject, we still focus in output and also input. For input, we focus for switch, and output maybe we focus for the buzzer. And as you remember, digital signal is only two states, either high and low, something like this. And in Arduino also can detect the digital input. When you give the digital input to Arduino, Arduino also can measure the states of the digital signal, either high or either low. And as you know, the digital pin, all digital pin in here is basically digital. It doesn't matter which pins you select here. Basically, the Arduino is digital. It's a computer with a digital operation. And the first we talk about the switch. This one particular switch, push switch we call it, or tactile switch. Anyway, and the shape is similar like this. It has the connection something like this. There are 4 pins where the pin A and D is connected each other. This one is one leg, and this also one leg, B and C. Anyway, in this particular shape, the symbol is like this for switch in electrical. In this case, the symbol is only 1 and 2, so this are connected each other. In this case, this is 1, and maybe this is 2, I think so. And this one is 3 and 4, maybe this 3 and 4. Anyway, when this pressed, this one is will connected. And this one is some kind of explanation. When you press it, you know, it's a terminal will connection, and no press, terminal disconnection, and there is no connection between 2 terminals with a narrow space among the 4 terminals. Okay, and you can select the A or D anyway, or B or C. It's up to you. Okay, next. This one is spoiler for usually we don't connect the switch like this directly to the source 5 volts to the pin input. You need some kind of another connection, because why? When this disconnected, I mean, when the switch disconnected, it when released, it give some kind of floating signal. Not sure, but it's not 0. something, or can be short. So is a connection like this is usually is not recommended. Okay. And for connection for switch, we need some kind of connection. We call it pull up resistor and pull down resistor. And in pull up, we call it pull up resistor because the position is above from input. And pull down resistor for next slide maybe. This one, its position is relatively down from the input. So we call it this one down and this one is up. So in the pull up resistor, basically, as you know, this one is type of connection. You can see in here what happens if the switch is state is released. It will give the 5 volts, I mean the high state of 5 volts when released. And when the switch is on, I mean press, it will connect it directly to the ground. So the sense of the input of Arduino will this one automatically become 0 states. So basically when release, for in case of pull up resistor, you know, when release, this will give a high. When you press the switch, it give the stage input as here 0 volt. You can see here release 5 volts and press 0 volt. And for pull down resistor, the switch position is above, but in resistor is down. So we call it this one pull down resistor. So as you can see in here, when switch is released, of course you don't have any voltage in here because it's released. So it's directly to ground. So when switch is released, the state is 0. As you can see in here, when released, the state is 0. When switch is open, release means open. And then when switch is pressed, digital states input, it gives states of 5 volts. When this give press, it is connected, it will give, of course, the 5 volts voltage in here. So the sense of the digital input, it gives the sense of 5 volts when press the switch, basically. So if you understand, I repeat again. This one is pull up resistor. Basically, when you press, it will give 0 sense. If a release, if you give 5 volts sense. And pull down, when it's pressed, it gives the 0 sense as the release. Okay, when pressed, it gives 5 volts sense. That is pull up and pull down resistor. So now we do experiment first using in Arduino. It has internal pull up resistor. So basically the connection may be something like this. This one kind of internal connection in Arduino. It has resistor, something like this. And you just connect the pin with the ground basically, because this call it pull up resistor. So remember when the press, it gives 0 cents, and release it gives 5 volt cents. So in here we have a schematic diagram to investigate the digital input. The function has only pin mode, of course. In here we add the function in here input pull up, right? Input pull up for pin mode. Usually pin mode input or output. In this case we added input pull up. And the digital read, and this function for reading digital input any number. In this case number 2, we read the sense from pin 2 for digital input, high or low. So in the schematic, pin 2 switch pin, of course, and pin 3 and for green LED, we already know how we connect LED. We studied last week. Just put this connection with resistor 2220, and then LED connection, anode and cathode, and this one negative LED connection to the ground. The basic function is actually when switch is pressed, of course, it should be LED on. When switch release, LED off. I think this one is wrong. Anyway, this one just a type of text. Anyway, this one in here, your code. We define LED 13, okay, and define switch. Let's see the void loop main state. We want to LED on when switch press. It means when switch press. Remember, when switch press, it is ground. It is 0 cents. When press is 0 cents, and release is 5 volts. This is high. So if the states are low in here, of course, LED high. Okay, this is correct. I think correct. Digital right, LED low. When state is high, this one is low. Yeah, this is kind of correct. When the switch is pressed, of course, it will give the states of low. So this one is 0, and this one is, you set the digital LED digital right high, and this state of high, it will off the LED. Okay, do you understand? I repeat again. So we define LED 13 as a schematic before. Here 13, okay, and switch is pin 2, okay. And after define this pin, we put in void setup. In here code pin mode and switch pin 2 input pull up for internal resistor, pull up resistor in Arduino, and pin mode LED output. Of course, you want to see the output from LED. Is it on or off? So in point loop, void loop, we will read the state of switch signal, either high or low. In here, it will give a 1 or 0. High means 1. 0 means low. Okay. When switch on for pull up, of course, it will give low states for pull up resistor. Remember, when switch is pressed, it will give sense of low, so you should turn on LED. In here, digital right, LED pin switch 13, pin 13 and high, and else, of course, it will high off LED. Very simple. Okay. I hope you understand the code and what is pull up resistor. Okay. This kind of video when switch is pressed, of course LED on. Okay. I also have in here setting for my Arduino, and this one is a code same in presentation. Internal pull up resistor, LED connect in pin 13, this one pin 13. Okay, switch to for this one, switch pin 2. Okay, and in void setup you write pin mode switch, it means the 2, and type input pull up. Usually we define input or output, but in this case we can put in internal resistor, activate internal resistor for Arduino by type input underscore pull up, and of course LED as output, and same we read the sense for digital for pin 2, so using function digital read in here, and of course this one is will give you 0 or 1. In this case low means 0, so if switch state means the switch condition, if low after reading in 0, so you write function on LED, so you type in here high, else digital write low. Okay, that one for internal pull up resistor. I have the video here, and you want to press the switch, so upload this code. So already upload, LED blinking, and you press the LED, press the switch, it will on the LED. Okay, that one is internal pull up resistor from Arduino. Come back to PPT. This one is video. Okay, next. For experiment 1-2, we still study pull-up resistor, but using external pull-up resistor. We just use function in here, pin mode number, and input. We set the pin number for switch in here for input, and digital read for state switch you want. This one is schematic diagram. For this experiment, we need two switches, switch 1 and switch 2. In this case, schematic like this. You put in 5 volts here and install resistor in here, and in the middle of between resistor and switch, this one connect to pin 2, and this also same. In the middle connection, connect and give the signal to pin 3. Something like this. This one is 5 volts. You give to 5 volts here. Okay. And this one is connection 5 volts, and you put the resistor here. A resistor here. Resistor 10 kilo ohm. 10 kilo ohm. Connect 5 volts. This line is, remember, for 5 volts. This one is for ground. Can I change the color? This one is for 5. For ground. GND, ground. This one is we want to basically using case condition, or switch 1 or switch 2 is pressed, LED will on. And if switch 1 and 2 press together, LED will off. If switch 1 or switch 2 is released, it means doesn't press, the LED will off. That's it. Very good example for N or low for you, maybe for next future. Okay, this one is connection. I repeat again. This one is connect to 5 volts, and you connect this one resistor 10 kilo ohm, something like this. Connect like this. Okay. And in the middle of connection, give to put in pin 2 in here. In this case, go to here in the middle from this connection switch, and this go here, pin 2, and this one is switch, of course, and this connect to the ground. Okay, connect to ground. And then for second switch, this one is connect to 5 volts in here, this case, this cable. Okay, can you see? Okay, and connect to this resistor. Connect this resistor, and in the middle of the connection between resistor and switch, connect to pin 3. This green line, 1 pin 3. Okay. And this one is switch, of course. This diagram, and connect to the ground. This pin. Okay. And for LED, same. We don't move for pin 13. We use pin 13. And this one for LED, you know, the resistor using 220. And this one LED connection and with the ground, and connect to the ground. Okay, this one is code. So using external pull-up resistor, external pull-up resistor, and you know LED is pin 13 and switch underscore 1 means switch 1, pin 2, switch or SW in here. I write the switch 1 in case of SW underscore 1. SW underscore 2 switch to pin 3. Define constant in here. Okay. And in void setup, of course, we define switch 1 as input and switch 2 also input. And LED, of course, set output. LED pin 13, okay. And switch 1 pin 2 and switch 2 pin 3. Okay, that one put in void setup function, and in void loop we will read the state of switch using digital read. Okay, in here you know SW underscore 1 is pin 2, this one pin 3. Okay, we will read using digital read function on pin 2 and pin 3, and we define in here variable as we call it SW1 state of, anyway, just a name. You can using a different name, is up to you. SW2 state. Okay, this will give a value of low. You know, low is 0, high is 1. Okay, so in here we want to this one, if the switch press together, LED will off. So we use the function of logical AND, and this one logical OR. If 1 or 2 press, LED on. So in here logical AND, if both are switch is pressed, it means for pull up resistors the state is will low. Okay, this one is will low. Remember, in pull up resistor, when switch is pressed, state is low. Okay, so if this equals 0 and pin 3 equals 0, so off LED. Digital write pin 13, LED pin 13, this one pin 13, low, LED off. Okay, and then else if condition pin 2, this one, we read the digital read high or low. If equal low, or condition means the if this both are one of the true, it will execute this function. Okay, in this AND logical, if both and are true, must true, this one should be off the LED. So that one AND condition, and this one OR condition. Okay, it will on LED, and else LED will off, means switch release, LED will off. That's what explanation of the code. I hope you understand. Very easy and simple. I repeat again. This one LED 13, switch 1, 2, switch 2, pin 3, and you set the pin 2 and 3 input and pin 13 output, and with loop read the digital read pin 2 and 3, and check the state high or low in here, and using logical, and for switch 1 or 2 both are low, digital output will off. This one will LED off, and this one if one off, either digital 1, I mean switch 1, switch 2 press, LED will on, and this one is off as condition. Okay, this one is video. If I press the switch 1 on, switch 2 LED on, but if you press both switch, LED will off. Press again, on and off, off. Okay, this one I pull down. Wait a minute. I have to install this, so you have to wait. So we need some kind of cable. This one I will move for switch 3. Okay, I'm preparing the connection. I think it's correct connection. Okay. Oh, you cannot see the switch actually. Okay, the setup I think is okay. So we go through here this code, and the code is same in like in the PPT. So we just upload. Let's see what's happened. Error. Oh, are you kidding me? Com3, com5. Okay, upload. Okay, already upload. So you can press this switch 1. LED will on, and this one switch 2, LED will on. Okay, if we both press the switch, LED will off. This one on, and this one press together. It will off. Okay, understand? Okay, I hope you understand in this experiment. Okay, that one in case of external pull-up resistor. If you have a question about this code, don't hesitate to ask me if you confused little bit, maybe in logical, or maybe how set up the switch. I hope you don't find any difficulties. Okay. So this one show you the video again, and the press the switch will on LED, and switch 2 will on LED, and the press both will off. Okay. So the next presentation, experiment 1, part 3. This is the pull down resistor. In this case, I don't do for you, but there is a video I think in this slide. Okay. This case the same. We do function, same function, pin mode, or pin number input, and digital read, and pin number, which pin you want to read for pin number. Yeah, which pin you want to read the digital state. I mean, the connection is reverse, then the pull up resistor. In this case, pull down resistor. The resistor is connect directly to the ground. In here, you can see. And at the middle of the connection, of course, the same. You put the go through pin 2 in here, and this one switch connection connect to 5 volts. For switch 1, this one switch 1, and this one is switch 2, and same So in this case, we connect using pin 2 and pin 3. And there is information in here. Switch 1 using pin 2 and switch 2 using pin 3. LED remain pin 13. And in here, the connection become like this. Can I delete? Okay. In this one, 5 volts. I will explain this first. This explanation is 5 volts connects to switch. Okay. This one. Enter more bigger. This one connect to 5 volts in here. This one 5 volts line. This one ground line. Okay. And this one switch, and in the middle of here connection you put in to pin 2, and this one a resistor connect to the ground. See the schematic in here. This is same, and this one 5 volts connect in to switch in here. Okay, and in the middle of a connection in here connect to pin 3, and the resistor connect to the ground in here. Okay, I think you don't confuse about connection. It's very clear in here how you connect the switch 1 and 2 for in case pull down resistor. The text same, the job is same for in case switch 1 or 2 press, LED will on, and switch 1 and 2 press, LED will off, and both switch are released, LED will off. The difference is only you set in here the state of low and high. From previous code, this one is low in case of pull up resistor. This one is low, but in this case, remember, because this pull down resistor, when in this switch on, pressed, it will give the sense of 5 volts. It will give the 5 volts in case of this one is pressed. This one is pull down resistor. So when a switch is pressed, it will give sense of the digital input of high state. So in this program, you just change the state high or low in previous code. Okay, in this one is previous code. Oh, cannot come back. What's happened? This one is previous code for pull up resistor. Remember, in this case, the state is low. Okay, because the reverse between pull up and pull down resistor, the state is different. So in case of pull down, the state is in here high. You just change the code high and low. So this one is remain same, digital LED high or low. Yeah, I think same. And this one is video for pull down resistor. You press, You can see, and when you press, LED will on or both switch on. But when you press both, LED will off. Okay. Okay, now we talk about buzzer. Okay, in buzzer, in your Arduino kit, there is two kind of buzzer available. The first is we call it active buzzer, and the second one we call it passive buzzer. The active buzzer is kind of the buzzer. You can see the figure in here. You can distinguish between active and passive buzzer. First, there are no some kind of the electric circuit here. This one is isolated circuit, and also it has label in here, remove seal after washing, something like this. And the passive buzzer, you can see the picture in here. Usually they not cover at the bottom of the buzzer in here. This is kind of PCB in here, and this one is feed metal wood, and this one for active buzzer. For active buzzer, it's to drive this. This one is not speaker actually. It's just make like a vibration sound. It's like using only require direct current voltage, DC voltage. So because there is the oscillator inside the PCB of the circuit inside the buzzer. So maybe there is a oscillator in here. Whatever you drive it with 5 voltage, it will give any sounds. It will vibrate. It will give the sound. And this one typically using piezoelectric means that this one is like a piezoelectric effect. It's reverse effect. When you give a voltage, the piezoelectric ceramic, this metal, this plate, it will bend like this. I'm not the electrical engineering, but in here anyway, if you give the some kind of the voltage, the piezoelectric will vibrate because there is oscillator circuit inside. This call it active buzzer. For passive buzzer, they don't have any oscillator inside, so it requires the alternating current or AC current. So we need the digital oscillating current, high or low, to drive, make a sound for this kind of buzzer. Anyway, this kind of the figure schematic how to this piezoelectric vibrates. When the voltage positive, maybe the ceramic plate vibrates like this. When you changing the how to say this one, orientation of the electron, this one electron go there and this one electron go there, this vibrates something like this. This will vibrates like this or like this when you change the state of the orientation of the source. So we need the alternating current or AC current. In this case, for passive buzzer, we drive the voltage, just make it like this, digital, high or low with certain frequency. if you say in here some kind of period, so the period is the frequency is 1 divided the period, so something like this. Yeah, there's no oscillator, of course, and it's also piezoelectric, I think, kind of piezoelectric. All right, this one have active buzzer and passive buzzer. So we do second experiment for passive buzzer first. Passive buzzer, you remember this you see if there is no solid cover, is a PCB like this. You can see the PCB on the bottom of the buzzer. That is a passive buzzer. Okay, just use understanding passive buzzer. Okay, and using the digital write and using delay microsecond. Previously, we study only delay function, that one in millisecond. Now we use this one, delay in microsecond. Microsecond. So we more smaller delay for millisecond to microsecond. Okay. The connection is like this. We use LED to make see the what's happened actually in buzzer. Just put same pin with the buzzer in here, same connection, and this one is ground. And buzzer can connect directly for 5 volts. I think this one is like this. Okay, you use the pin 2 in here, and this one is code. I will make some kind of sound for passive buzzer, and this one of in the pin 2 buzzer and delay, and for its setup, of course, buzzer output in here. And in this code, I just want to drive digital output for 50 times by when we changing the delay. I mean the changing the period of this from 5 to more higher 250 microsecond, and see what's happened by increment of 5. So basically we want to just use change the delay 5, 10, 15 until 250 delay, and we drive the signal for 50 times inside the for loop in here for 50 times of signal like this. This one microsecond, remember, not millisecond. Okay, and this Python. So okay, I will show you in here. Maybe this one is very simple, and you can see this one is my DeX. Use of pin 2. I will take off this all. Wait a minute. Okay, this one is type kind of connection or buzzer. Passive buzzer is on. There is accident for video. Sorry for that. Okay, I already connected in here with passive buzzer with LED, of course. So I have some kind of this one, and basically buzzer pin 2 and time delay and output. Okay, and we change it period of this one. Time delay, of course, changing from 5 to 250 in here. Okay, and we just drive the signal 50 times. See what's happened. We just want to see here this siren horn tone. I mean, this upload. Yeah, that one is sound from buzzer, very annoying. You can type of wire. If you don't want to, okay, that one sound for this code. If you type of reset, you can hear sound again. That one the sound from 50 times the digital with the different period. You can do next experiment. This one, in case of using my tone function. Same, we use you can see in this code from book page 49. This previous function I make it by myself. This one passive buzzer, so there is no in book, I think. So in this case there is a book, but in the book maybe we can change this float variable times. I think no need that. We can use it using integer, I think. So we have the in here tone for music. You know, do re mi fa sol la si do, maybe this kind of type of frequency. Okay, and this one pin buzzer, pin 2, and number of frequency, because there are 8. 1 2 3 4 5 6 7 8. This one 8 frequency amount, and you type of this tones of array. This put this constant frequency in here in tones array. Okay, and you make a function my tone, and this one pin number, integer pin, and frequency, of course, and this one you put how many times you want to drive this signal, how many times you want to drive this signal. The signal is actually only like this, right? Only high and low with this period. And this one is time. So this one is time divided to half of t. Sorry, because this one is one period. This one period. This one half, and this half. Half on, half off. So in here, in my tone function, we want to drive the delay with the microsecond. My network is off, so what's happened? No matter, this one is changed to microsecond divided frequency. Frequency is this tone. This one is frequency. Okay, and this one, and is how many times you want to play this signal. How many times? This one 2 times, this one 3 times, this one 4 times, 5 times, 10 times, and so on. Until, in this case, we just set times is in here 1. No matter. So, okay, no problem with this void my tone. I think you understand this code. Okay, in void setup, no special. Set the output buzzer, and in void loop, we want to play every single frequency. This one is do re mi fa sol la si do. The tone is so this one buzzer, you use your function. This one function name my tone, in here my tone same, and you put the pin first, pin buzzer, of course, and this one frequency. This one frequency, and this number of times. How many times you want? Oh, kakao, okay. How many times? Too many ink. How many times you want to play, and you put something kind of delay, no matter, in here, and I use while one in here. If condition true, it will do nothing, because you do put any command in while loop in here. So basically, this is that code. In order to Arduino not to operate again and again like operation continuously. So in here, I think you understand the function of this one. First, frequency, of course. This one integer, buzzer, pin 2, number of frequency. This one because there are 8 in here. This one number of tones, frequency, of course. And you make your function. We call it my tone, my underscore dash tone in here. And you set pin, frequency, and how many times you want to play the signal. And this one you define period, which is the period is divided frequency, 1 divided frequency, that was is second, but in this case microsecond. So multiply 1 million divided microsecond, divided frequency, and this one how many times you play the tone. So times multiply frequency in here, and this one useful for in this for loop. This signal you play digital high and low. Okay, with period of half. Okay, and this one buzzer output. Of course, set output. We want to send the signal to the buzzer. Okay, and for loop, we want to play this all frequency. So using for loop from array 1, array index 1, array 0. This one CC, DD, EE, FF, GG, AA, BB, CC2. So this one using for inside for loop in here, you type your own function, my tone function, and buzzer, pin, buzzer, and this one frequency, tones in here. This one I is index of I. Index 0 means you will play. CC means this one, and if case of 2, you will play this one. If case of 3, you will play this one, and so on. And then there are delay. And then this one while loop for if true, it will do nothing. Okay, I will show you the sound of something happened with my connection. Okay, now connect again. Is it still play? I don't think so. Have to end show and check my Droid cam again. Okay, this okay, this buzzer still same connection. This one passive buzzer. Okay, and we want to this kind of function. I already explained in PPT. We just upload this one. COM5 course upload. It will play tone this kind of frequency. Okay, if you can press reset button and play again. Okay, that one is tone for this kind of frequency. Okay, so we move to next experiment. That was a Python function. So we discuss about active buzzer. Okay, for active buzzer, relatively easy. Whatever you give the signal, I mean the signal 5 volts, it will on the buzzer. So we just give digital write and delay. The connection remains same in here using pin 2, and this one active buzzer code. I make this code by myself, and we want to just see what's happened if we change the period of delay time. We just change delay time in here, high on low, from 200 to 5 minus 5. So this one will give the delay time something like something like this, something like this, something like this. 195, 155, something like this. Go down until 5, I think. And we just do simple this one, and in here we change the active buzzer in the circuit. This one is active buzzer. As you can see, it's not focused. Okay, just replace. And in here, the code nothing special, the same. Only we just do delay and high on low with changing the delay time from 200 to 5. So this one just upload, I think. It will give the sound more longer to more faster. You can see the LED blinking in here. This one is active buzzer. You can change in here using while and upload again. Okay, we will stop because after true it will do nothing. So that one active buzzer is very easy to drive because it's only use the direct current. So whatever you give the 5 volts, it will give the noise sound for buzzer. Okay, That one is active buzzer, and active buzzer is this one is spoiler, just announcement, relatively easier I mean, than passive buzzer to operate. This one, and in this case we can use for both buzzer using the built-up function, I mean function from the Arduino. We call it the tone, and this one pin, frequency and duration, how long you will play the sound. Similar function which we made previously, but in here we use tone function. Oops. Tone function in here, nothing special. This is same. Pin 2, let's set up, and using tone function and set the pin and set frequency and set duration, how long you play the tone. And if you need delay, you can put delay in here. And this one, well, if true, will do nothing. Is there any video? Oh no. I will show you to you. In this case, this one similar. In this case, I installed the active buzzer. Yeah, active buzzer. And you just upload this. Okay, upload. Compiling sketch, uploading. Okay, it will on for 3 seconds. If you want to change for passive buzzer, it also give an sound similar sound. Just press reset button here. It will give a similar sound with passive buzzer, more higher sound. In here, type again. Okay, if we change the frequency, see what's happened. Frequency like similar frequency in here, maybe do frequency 261. Let's change the frequency 261, and then you can upload. Okay, that one sound same like previously we do. If you want to play again, just press again reset button. Okay, that one using tone function built up from Arduino. Okay, I hope you understand the basic function of this kind of buzzer. That one, this one, our function is similar with the tone function. Frequency okay, 3 second delay okay, nothing special. Okay, and maybe you want to play melody for active and passive buzzer. In here you can typing this website Arduino. Can I copy paste this chart and go to this type kind of website? This one using tone function. Connection of buzzer, something like this. In this case, pin 8 meter. And this one is kind of tone. You can copy and paste in the notepad. In the notepad. Copy, and you make a notepad in here. In this case, you just save as in the library Arduino document. There is Arduino library. In this case, I already make the folder pitches in here. Folder pitches. So the type is you type kind of pitches.h. Type it pitches.h. Remember, and you just save it. In this case, I already have it, so I don't need to save again in here. Okay, after that, after you save as, wait a minute. Oh, Arduino libraries, pitches. I already have this one, pitches.h. Similar code. I mean, similar library. Note. Okay. And in your Arduino, this kind of instruction, save it, and then in Sketch, go to include library, and add zip library, and you select a pitch folder you have been created. In here, maybe there is warning, but you just ignore it. Maybe there is warning, some kind of subfolder of your sketchbook is not a valid library. You just ignore it. And in include library, you will have this kind of pitch. Okay. And this kind of song 학교 종이 탱탱탱. 학교 종이 탱탱탱. This one you put the include pitches and type of pin. You set pin second, pin 2 in Arduino, and this one is song for this one 학교 종이, and you can do this one and this one array song. Okay, and pin mode output. Okay, and in loop you play this type of melody for 28. This one there are 28. This one 28 melody, and this one for duration playing delay millisecond, and this one while true let's do nothing. For this one ultrasonic distance sensor. Okay. I will upload this melody code. This one same code in the presentation. You first have to do include library which is I presented before. Oops, excuse me. There are pages. This one, pages folder. Include pages. Oh, already pages. This one. No need this one. Again. Okay. You should do that, and then you can upload. Okay, that one is song for Hak Yu Chongi. Thank, thank, thank. Okay, this kind of end of presentation for buzzer. You want to play again the music before end this presentation of buzzer? Okay, thank you for listening music. Okay, next we'll study for ultrasonic distance sensor. So for this ultrasonic distance sensor, basically it has principle like this. See in the diagram. Basically, ultrasonic sensor will generate ultrasonic, ultrasonic sound waves and evaluate the reflected wave. For example, in here, the sensor will generate the sound wave in ultrasonic, and if there is a obstacle object or detected object, it will reflect it, the sound wave, and go to the transmitter here and give the signal to the microcontroller by give the echo time pulse, something like this, this long pulse like this, and when there's a drop means the distance changing, I think so. And the beginning we have to start pulse. Oops, sorry, we give the something kind of a pulse first to the sensor, and the sensor will give the signal something like this. We call it the echo time pulse, and this one is kind of a basic definition of ultrasonic. Maybe you know, and we cannot hear this ultrasonic sensor because the sound wave is about more than 20 kilohertz, maybe 40 kilohertz. So we cannot hear because the audible sound is around 20 hertz to 20 kilohertz, and this kind of ultrasonic from 20 kilohertz to 1 gigahertz, and hypersonic, wow, this one 1000 gigahertz. And this below here also we cannot hear subsonic. So, and this one is a dolphin. It has can hear about this frequency 170 kilohertz, and bat, bat, which stay in the maybe in cave. The animal bat has audible here in this range 100 hertz to 200 kilohertz. Very interesting. Anyway, how to know the distance. So basically we use the sound speed velocity, which we know sound speed velocity is about this 340 millimeter per second. So you convert to this unit centimeter to microsecond. So we detect the requirement time to transmit to reflect. So basically this one is a simple calculation, which is 2 times of length, but simple calculation 2 times of length divided the velocity. So this one, if you measure, for example, in here in this case 10 centimeter, you this sound is travel 2 times. This one first 10 centimeter and go back also 10 centimeter. So this is 2 times 20 centimeter. So divided sound speed, so become time, which defined by this echo time pulse. I hope you understand. Okay, so basically the distance is just we measure the times transmitted time during the sound go back from here to here, from here to here. So the distance is very simple. Just we know times using function pulse in, and this one sound speed divided 2. So we can using this equation. So we know the time period during the transmitted to reflection, and you just divide this function, this number 89. Sorry, about 88.82. So we can know how long the wave travel. All right, that's the very simple calculation, which you can see this type kind of ultrasonic distance sensor. You can see and search in internet many of example of ultrasonic distance sensor, and I think the equation is relatively almost the same. And this experiment, what you need is of course Arduino Uno and the breadboard and this sensor SC-SR04, which only consists 4 pin 5 volts VCC, and trigger pin, and this one echo pin, and this one is ground. Only 4, okay. And objective this experiment, understanding distance measurement of course, and using pulse in function. And first experiment 3 part 1, pulse in and set pin number, and we want to detect the when the basically the pulse is rising. I think so. And the delay microsecond. Okay. And the measure. This one is a schematic. The voltage go to 5 volts in here. 5 volts cable pin, and trigger we use the 7 pin, and echo pin use 6 pin, ground to ground. Okay, this one pin trigger and echo pin 6. Okay. Okay, this one is first code for experiment 3 part 1, and of course you set the trigger pins pin 7, and echo pin 6. And then we use distance for long variable for distance, and duration long variable. Duration is we want to measure the from the input using the function of pulse in here from pin 6 when the pulse is rising. We want to know the duration when the pulse is rising. As you know, the echo will give the input like this, and we want to know the duration when the this rising, when the high. So we can know time, how much second from echo pin when the time the pulse is rising. And nothing special here. Serial begin in void setup. Okay, we want to display in serial monitor. Use serial monitor at baud rate 9600, and pin mode. Of course, pin trigger we have to set output, and echo set input. Pin 6 input. Okay. In void loop, first we send pulse for trigger. As I said, we just give the for wrong draw. Okay, we give the sorry, this right this one just like this pulse. This one 2 microsecond, and this trigger is 10 microsecond. Okay, just give this pulse in this state. Okay, just give a pulse, and then we read the digital pin for pin 6 echo using pulse in function when the pulse is rising. We want to know how much this duration when the sensor give the signal, when the period this time when from reflect sound duration, of course, and calculating distance in centimeter. Just simply we already know duration of time divided 58.82. This is distance, as we already learned how to calculate previously in slide this number. Okay. Oh, sorry. Go back. And then display in serial monitor. Serial.print distance. Okay, serial.print. You display the number, and then you display the centimeter, and then using delay. And the output will be like a distance. Wow, very bad. Distance. Very bad writing. Distance, and you will display any number here, maybe 10 or 9 or 8, and you display centimeter here. Okay. And this one is kind of video. You measure distance. We will have the number distance 10 or 9 centimeter. As you can see, is about 9 or 10 centimeter. If change to 6, we show the 6 centimeter in here. 6 centimeter. Okay. Okay, very interesting. So I already installed in here in my desk, on my desk, the distance sensor. Okay, and you can upload if you already type the code. Oh, okay. This code is same in PPT. The distance duration divided this number. I will not explain again. Okay, we just upload. Oh, why there are two comp? Very interesting. Hello, two comp. Upload. There are two comps. Okay, this one. Upload it, and this one display in comp, and you can see the distance is 30 centimeter because in my this video I have obstacle this leg of my smartphone tripod, so it is this they detect 13 centimeter. If you put your ruler something obstacle in front of that sensor, it will give 5 centimeter. If you close 4 centimeter like this, okay, it will give 8 centimeter, about around 8 centimeter, something like this. You can try at home by yourself, but in the sensor, if too much close, it will give error because the sound maybe not reflected, and it will give the some error measurement. So there is a limit of the sensor. Do not too much close for measurement using this sensor, I suggest. Okay, that one for your first experiment. Mm, okay, go back to presentation. This kind of video already seen. Okay, next experiment. If more than 200 centimeter and less than 2 centimeter, just display out of range. It is a limit of the sensor. So in this code, we just give some kind of if condition in here. Very simple. If distance more this one, just put out of range. You can do in yourself in your home. This one. Another else is similar. You can upload in here. This one. If more than 200 centimeter and or less than 2 centimeter, just print distance of range. And another is similar distance print ln centimeter and delay, and you can upload this one to the Arduino. Okay, already upload, and you can see in serial monitor. If you put the sensor obstacles in front of sensor more close, it will show out of range. Okay. Okay, this one is kind of experiment. I think easy for you. And maybe you can use the new pink H library, which I think in the book for new pink is instruction is available, I think. So just go to sketch and include library, manage library, and you just type new pink like this, and you just install. Very easy. Okay, just in this case using new pink library and define constant 200. Nothing special. This one same, and using this object, make it this object first. New ping sensor, trigger echo for pin, and maximum distance 200. Okay, this one serial setup, and then for it loop, use sensor dot ping function, and for distance duration, divide it us underscore round trip underscore centimeter, and this one display for your sensor. But basically, I'm not sure this code is sufficient for you. But in my case, this program is some kind of give the when the out of limit, it will show the 0 in this case. In this case, always display if the out of range, it will show the 0. I don't know. Oh, this one homework, but later will show you. This one using new ping dot h, you know, the include library, manage library, code type, and updating. So new ping already installed. So if you haven't installed it, there is a button in here. So I already installed in here. So new ping, maximum distance, and using this definition. Okay, create the object sensor, new ping object sensor, this one, define pin and echo, and just simply use like this. Maybe there is a definition of this, I think similar with our previous experiment, I think. So just upload this one. In this case, in this particular case, using new ping, we don't need define in here function for send pulse. So we don't need that. We just measure in here. Maybe the program already has in here when you create the object, maybe. So I already uploaded. See, in this case, sometimes it's give some kind of It's not satisfied for me. I think I don't recommend using this kind of program. See, this always show a zero something. It's read a zero, zero. I'm not sure. I think our program previously is much better than this new ping. I don't know. Maybe if in your case, if you use a new ping better than previous program, you can use this program. But I think this one might this our previous experiment is a little bit better. It doesn't show any zeros. This one, this program is better than using new ping.h. I think. I don't know. See, there always show 13 and it's show very stable. And I don't know. I don't know. This one, I don't know. But in the book, they suggest using this new ping. If you upload this, this measurement is something length of a not stable measurement. Okay, I just show you how to do variation of code. It depends on you. You want to use this one or previous one, or you can use your own code. It's a freedom, but I will not recommend using this. Okay. I think this one is better. Okay. See? This one a little bit stable in our experiment. Okay. 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 The next is homework. And your homework is very easy. I think we just you have to do basically only use this sensor, active buzzer. You know active buzzer, remember, and LED. Your job is to drive LED and buzzer when ultrasonic sensor measure less than 5 centimeter and display in serial monitor your distance. The text is very simple. Your homework. If less than or equal 5 centimeter, the LED and active buzzer will on. And more than, just off. This kind of pin assignment. You can use this pin assignment or another pin assignment. It's up to you. It's not a big deal in pin assignment. It's up to you. And this one schematic diagram. Okay, it's nothing special. Your text is only less than equal 5, buzzer on, and LED on. If more than, just off. It's very simple. Okay, I hope you understand the text. This one, individual homework. Oh. And this one is video for your homework. You see, and if about 5 centimeter, it will on. We increase the sound like this. Okay, that was your homework. And thank you for this presentation. I hope you understand my lecture, and I hope you guys keep safely. And okay, thank you. See you soon.